Today we're going to be doing a numerations problem, and we're going to write 4,560 in Babylonian. The first thing we need to do is figure out what base Babylonian uses, and it is base 60. So I'm just going to write down base 60, just so we remember. And from there, since we know our base, we're going to take 60 to each power until we surpass this 4,560. So we'll start with 60 to the power of 0, and any number to the power of 0 is always going to be 1. We'll do 60 to the first power, and that's just saying 60 one time, so that would equal 60. We'll do 60 to the second power, which equals 3,600. We'll do 60 to the third power, which is 216,000. So at this point, we have surpassed this number, so we can just stop there. We don't need to go any further. And then to convert our number, we're going to have to use like a long division to solve and convert our number into Babylonian. So I'm just going to rewrite our number that we're working with, the 4,560, and just make like a little bracket around it, like that, because that will give us enough space to write down and keep track of everything that we'll need to have when we get to the end. So what we'll want to use is, this number is too big. We need a number that can fit into our 4,560. So that looks like we can use the power of 60 to the power of 2, which equals 3,600. So I'm going to set the 60 power of 2 off to the side so we know what we're starting with, and that is 3,600. And we can only use that number once. If we did it twice, it would be too high for this number. So since we're only going to use it one time, we're going to put 1 over here. And then I'm going to put 3,600 down below from our number that we started with, because we have 3,600. And we're going to make like another little bracket right below that. So from here, we're going to take the 4,560 and subtract the 3,600. And that gives us a total of 960. So since we started with 60 to the power of 2, we can't skip around. We have to go in order till we get to 0. So the next one we have to use is 60 to the first power. So I'm going to put 60 to the first power, and that equals 60. And how many times can we fit 60 into 960 before we're going over? And that works out perfect for this one. It works exactly 16 times, and you would get the 960. So again, we're just putting how many times we can fit it in here, this number, before we're going over. In this case, it worked out to exactly an even amount of times, and at that amount of times we're going to put over here to the right. So I'm just going to use another little bracket below there. And again, we're going to subtract these numbers. So 960 minus 960 is 0. And we're not done yet. Even though you're ending up with 0, you might think you are done, but we have not yet gotten to the power of 0, and we have to use that. We have to go all the way down. So I'm going to put 60 to the power of 0 because we know we have to use that. And that equals 1. So we'll still put that there. So how many times can 1 go into 0 without going over? It can't. So we don't want any of them. So we're just going to put 0 over in our right-hand column because we don't really want any of them, but we have to account for that 0. So then we'll still put our 0 here and make our little bracket just to have it all organized. 0 minus 0 equals 0. And we are done with our long division. So from here, the numbers that we really want to focus on are their right-hand column. The 1, 16, and 0. So from this point, we need to know what number system the Babylonian system uses. So they use some shapes, and they use a downward facing triangle, and it is shaded in, and that equals in their number system as 1. And they also use these little chevron looking things, and those equal 10. And the only other number symbols that they use are upward facing little triangles, not filled in and stacked on top of each other, and those equal 0. And that's all the numbers or the symbols that they use for their number system. So what I'm gonna do is I like to start from the bottom and work my way up. So our first number we have to work with is 0. And we know these two triangles equal 0. So we're going to put our 2 triangles down. And since we're working from the bottom up, we're going to go from right to left. So that is 0. That's, you can even put it up here too if you wanted to, kind of keep it organized. So we have accounted for our 0. Now we have to count for our 16. So we know a downward facing triangle equals 1, and the chevron equals 10. So we have 16. So we want to start with our 1's place value, which is 6. So our 1 place value would be our triangles. So we need 6 triangles. So 1, 2, 3, 4, 5, and 6. So those account for our 6 in our 1's column. And now we have a 1 in our 10's column, which would be at 1 chevron. If you had 26, you would have 2 chevrons and then your 6 triangles. So I'll put one of those. So now we're done with our 16. So that's our chevron plus chevron plus 6 downward triangles. So that one is accounted for, and then we can move up the ladder again. So now we have 1, so 1 is in the 1's column, and we'll just need 1 downward facing triangle and fill that in. You can put over here. our triangle and fill it in. So we can go back through if you want. You can go then left to right and down if you wanted. We have one downward facing triangle. We have 16, where ones is in our tens column, and so our chevron looking thing equals 10. So that's in our tens column. We have one of those. Our 6 is in our ones column, and our downward facing triangles equal 1. So we have 1, 2, 3, 4, 5, 6 of those. And then our bottom number here is 0, and zeros are our 2 triangles facing up on top of each other. So we have all of our numbers accounted for, and this would be our answer. So that is how you write 4,560 in Babylonian.